Hello everyone, this is Professor Gant and we are in our fourth video in the video series for Module 4 homework for Math 109 General Education Mathematics. This video we will be covering the topic of equations of variation, and so we will be doing problems number 32 and number 33. And so before we get started, on this particular question, I need to give you some background on what equations of variation are, as well as how do we decode reading a problem like this and know what equation to use. So when we talk about equations of variation, we're saying that two variables are related to each other by some constant, which we call a constant of proportionality. And so depending upon how the two variables are related, that lets us know what equation that we use. So for instance, the most simple one that we have is called direct variation. And so direct variation is just the equation y is equal to k times x. And so here we say that y varies directly as x. And so a good example of this is, let's say you have a job and you get paid hourly, and your wage is $20 an hour, okay, or $20 per hour. So K, which is the proportionality constant, in this case would be the $20 per hour, okay, that would be your K. And the equation would be y is equal to 20x. And of course, this tells us if I know how many hours I work, then I know how much I get paid. Okay. I also can figure out, if I know how much I want to be paid, then how many hours I have to work to be able to be paid that. So in that sense, we know that how much money we make is directly tied to how many hours we work. Okay. And vice versa. So this is why this is called direct variation. Now, another type of variation that we have is called inverse variation, okay? Or it's inversely proportional, okay? So we got inverse variation here. And this is y is equal to k divided by x. And so the reason why this is the way that it is, of course, this constant here is going to be the same. But here we're saying y varies inversely as x, okay? So that means here, if y is going up, then that means that x is going down, and vice versa. So let's say, for instance, here my k is just equal to 1, just to make this simple. And I have y is equal to 1 divided by x, okay? If I plug in, let's say, x equals 2, then that means y is just 1/2. So here we see that x is, when x goes up, y goes down. Let's say I plug in 3 for x. So if y is 3, sorry, if x is 3, then y is 1/3. So we see as x continues to go up, the y value continues to go down. But it also works in the other way. So let's say here that x is equal to 1/2. Then in this case, y is equal to 1 divided by 1/2. And if we do 1 divided by 1/2, we know that 1 divided by 1/2 is just the reciprocal of 1/2, which is 2. So here we see that x is lower, y is higher. Same thing can happen if I plug in 1/3 in for x. And if we do that, then we have 1 divided by 1/3, which ends up being 3. So x is low, y is high. So that is what we mean by inverse variation here, that the higher values I plug in for x, the lower values I plug in for y, and vice versa. Meaning the lower values I plug in for x, the higher values I'm going to get for y. Okay. Now, we also have other types of variation called joint variation. And I'm going to get rid of all the stuff down here. But joint variation is basically just a direct variation, but it's with two variables instead of one. And so here we would have y is equal to x, y is equal to k times x times z. Where here we have direct variation amongst two things with respect to y instead of just one thing, okay? And then, of course, everything else that we have is just combinations of this direct, inverse, and or joint variation, okay? So when we look at the problem that we have here, we're trying to read this to see, are they telling us something about direct variation, inverse variation, or joint variation? And of course, they're going to use the word proportion or proportional instead of variation here, but that's really what it is, okay? So here it says, assume that the amount of heating oil used during a given month is inversely proportional to the outside temperature, okay? So here we have amount of heating oil is going to be inversely proportional to the temperature of the oil. And do you see how we use the inverse variation equation to come up with that? Where A is the amount of oil and T represents the temperature of the oil, okay? So normally with these types of problems, the first sentence always tells us what equation to use. The second sentence gives us information about all the other variables in the equation so that we can find out what the constant of variation is. And so in this case, we know that we need to find out what K is so that we can find out any other relationships. So we need to know a certain amount and its corresponding temperature. So here it says, if Andrea's pet store uses 509 gallons of oil, so that is the amount for this particular situation here, in a month, that has an average temperature of 40 degrees. So we have this being 40. Get that 4 looking right. Then we want to know how much oil should she expect to use in a month with an average daily temperature of 38 degrees. Okay, so we need to plug in 509 in for A and 40 in for T so that we can figure out what our variation constant is. And then after that, we'll use the equation with the variation constant in it to figure out the answer to the question that they're asking us about. So to solve for K, here we know that we can just multiply 40 by both sides here. And it's kind of hard to write over here. We're going to do 40 times that. And here that reduces to 1 and just gives us K. And of course, if we do 509 times 40, that will be 20,360. So that is our variation constant. And of course, from all this information here, we now know that our equation of variation is A equals 20,360 divided by T. And so now what we're being asked is how much oil, how much oil would she expect to use in a month if the average daily temperature was 38? So here to answer the question, we want to know what's the amount given that the temperature is going to be 38 degrees Fahrenheit. And of course, we know our equation is 20,360 divided by T. And of course, T in this case is going to be 38. And all I've done here is I've placed the number 38 here, but what this would really be, if we were just writing this in general, is we have some function A of T, and here this would be 20,360 times T. And all I'm doing here is just replacing T with 38. So just in case you didn't follow that notation, that is what I'm doing. So we got 38 here, 38. And of course, all I need to do now is just take the 20,360 divided by 38. And we get, oh yeah, that is, yeah, I'm looking at my calculator here and I have a decimal and I'm going to see if that ends up being a clean fraction or not. Okay. So fraction wise, if I just divide the numerator and denominator by 2, I end up getting 10,180 divided by 19. Okay. And so the only reason why I'm considering this is because it says type an integer or a simplified fraction. Okay. So if you were to put this into your calculator, the 20,000 divided by 360 divided by, the 20,360 divided by 38, you would get like 535.7894737. Okay. So, and I'll go ahead and write that. 7894737. Okay. But the thing is that this does not want that answer. Okay. So according to what the directions say, I need to write it as 10,180 divided by 19. All right. And they're saying that they don't like that. So we got to see what's going on here. All right, so what I think I'm going to do here is I think these instructions aren't correct. They're telling us to type in integer or simplified fraction, but they also need to tell us that we need to round if that's the case. So what I'm going to do is if we round to the nearest integer, we should get 536. And I believe that may be what they're looking for here. Yeah, okay. So these instructions here are incorrect. So, yeah, because I knew this had to be the answer, but if they're wanting us to type in an integer or simplified fraction, then that means that it really just should be round to the nearest integer in this case. So just one of those small things. Sometimes these questions are like that. But at least you watch this and now you know why it ends up being that. All right, so let's move on to number 33. I believe that's the next question that we have. All right, and this one's going to be very similar. So I'm going to go ahead and erase all this and then we'll go ahead and work it out. All right, so for this problem, it says if the temperature is held constant, the pressure of gas in the container varies inversely as the volume of the container. So if we let P equal the pressure of a container, then we know that this varies inversely proportional to the volume. So that would be V. So P equals pressure, V is volume. So here it says assume that the gas pressure in the piston cylinder, which is the container, is 3 pounds per square inch. So if pressure is 3 psi, and that's the units for it, when the volume is 120 cubic inches, so that's inch raised to the third power. If we have that, then it says if the volume of the cylinder is reduced to 75 cubic inches, what is going to be the pressure of the gas? So of course, the first thing that we have to do is figure out what the variation constant is based upon the information given. So our pressure here is 3 and our volume is 120. So just like how we did last time, we'll multiply both sides by 120. 120 times 3 gives us 360. And this reduces to 1. So we know from here that our equation of variation now is going to be P is equal to 360 divided by V. And so now we're asked to say, and let me go ahead and rewrite this way. So P of V, meaning that we have to plug in volume to figure out the pressure. So here we're asked to reduce the volume from 120 cubic inches to 75. So basically, if we plug in 75 for V, what is going to be the pressure? And of course, all we need to do is take 360 divided by 75, and we get 4.8, and this is going to be PSI. Okay, so we can see basically if the volume goes down for that particular container, then of course the pressure pounds per square inch is going to go up. So here it says round to nearest 2 decimal places. So I'm just going to type in 2 decimal places there. See if that works, and we're good to go. Okay. So for both of these questions, it ended up being an inverse variation type problem. But you see that once we know from the wording of the problem what equation to use, the problem is relatively simple to do. And so this will conclude the video on equations of variation. The final video that I will do will be on geometry topics, which will be complementary and supplementary angles, dealing with similar shapes as far as the relationships in between the sides and the angles of those shapes, calculating the angle for side of a polygon, or things like that, and using the Pythagoras theorem. So the final video, if you're doing this in order, then you should be watching that one next.